Today we're going to be talking about linear and exponential growth problems. Now these are worth 35 points on your average SAT, so this is an important one to know. So our approach is going to be to identify linear and exponential growth problems. We're going to break down the question, we're going to build a formula for linear and exponential growth questions, and then we're going to solve a practice question together. So how do you identify these? Well, this concept will test your understanding of the difference between linear growth and exponential growth. These problems will mention something growing. Sometimes it's a bacteria population, sometimes it's a population of people or animals. So if something's growing, it's probably this concept. And you'll often be asked to find a value at time equals maybe 1 day or 2 weeks or something like that, or identify the correct equation. Now, before we look at our practice question, I'm just going to show you a little bit about the difference between linear growth and exponential growth. So linear growth, every increment increase in x value is going to be the same increase in y value or decrease if it's decay. And so, for example, if x increases from 0 to 1 and y increases 5 units, then when x increases from 1 to 2, we'd expect y to increase 5 units again. But for exponential growth, the amount that y increases, or for exponential decay, decreases per increase in x unit is going to be different. It's going to change each time. And so let's look graphically. Linear growth is probably a lot more familiar to you. It's going to be this straight line where, like I said, for every unit increase in x here, we have a corresponding same increase in y for growth, or obviously a decrease for decay. Now our exponential growth is going to look something like that. And so we can see as our x's change, the amount of y it's changing by is increasing every single time we increase the number of x's. So we could go from x equals 0 to x equals 1 to 2, and we have this little increase here versus this a lot bigger increase when we go to 2. And so we can see that for every x change of the same increment, our change in y is actually different. And so this is telling me exponential growth. So here's the formula we're going to follow for this concept. We're going to decide what type of growth we have. We're going to figure out how our growth is changing. And then we're going to find the appropriate answer depending on that growth. So here's an example. Step number 1, we're going to decide our type of growth. And our question reads, a video goes viral and its views double every 2 days. If initially has 1,000 views, which equation models the number of views, v, after d days? Well, it's telling us that it doubles every 2 days. And so for me, doubling every 2 days is going to be exponential growth, because let's say we started at 100. After 1 day, we increase 100 to 200. And then after the next day, we increase from 200 to 400. So the first day we increased 100, but the second day we increased 200. So that's going to tell me that we're changing different y values for the same x value difference, and that's going to be exponential growth. So all of these options are actually showing us exponential growth, and so we know it's not linear, but let's figure out which one it is. And so we're seeing how the growth is changing, and we're looking for which equation is going to be right. So we're looking for the equation that's going to double it every 2 days. And so before we look at the equations, I'm just going to show you the general format. So value at time equals value at 0 times whatever your growth factor is to time. So this is going to be the general format for exponential growth. So you can find whatever your value is at time by starting with your value at 0, multiplying it by growth to the exponent of time. So let's see which one satisfies these. So we're looking for one that starts with v at 0, which the equation tells us v at 0 is 1,000 views. And so all of them at 1,000, we're looking good there. Now we need to look at our growth rate. It's doubling, and so I'm thinking our growth is 2. So that's going to rule out B and C for me. And we can actually see C is 0.5, which would represent exponential decay. So it'd be decreasing, so that one's definitely wrong. Now between A and D, the only difference is this time value here. So if D is the number of days, and we know that our video doubles in views every 2 days, we need to take the amount of days we have and divide it by 2, and then it should double that many times. And so that's what D is doing. We have D divided by 2. That one's going to be correct. Answer choice A is wrong because it's doubling every single day. It doesn't divide this D by 2, and so that one is wrong, and our answer is D. So for these, Desmos can definitely be useful. So let's go back to this question that we had. And I'm just going to plug this into Desmos so you can see what the graph looks like, and we can do a little bit of a sanity check. Now that we're in Desmos, we have y equals 1,000 times 2 to the power of x divided by 2. Now, an important note here is that Desmos only takes x and y's, and so make sure when you're putting in an equation in Desmos, you're only using x and y, because if you're not, Desmos is not going to take the equation, so just convert whatever you have to x and y. So we can see our Desmos graph here. An important note is that we're going to have to scroll out of Desmos a little bit to see the whole graph. And you might be seeing these negative values and be confused. How is there a population at negative time? In this case, the negative values aren't pertinent, but if we click on 1,000, we can see 0,000. So at time 0, we have population 1,000. That's looking good to me. Another check I can do is I know it's supposed to double every 2 days. And so I want to see where we are at 2,000. It should be x equals 2 if we did this one right. So let's scroll here. Yep. So after 2 days, we've doubled from 1,000 to 2,000. So this is showing me that this equation is correct. So good luck on these.